Hello everyone, this is your learning partner, and the basic purpose of this video is to share some knowledge about Cloud ETL, that is Azure Data Factory. But first of all, I will elaborate some basic concepts of ETL, so listeners who are new to ETL concept can also take benefit from it. This is my first video and I need your help to keep motivate and encourage me for future videos. So for any kind of suggestions regarding this video, you can comment below and do not forget to subscribe to my channel. Let's get started. The topic of our today's lecture will cover traditional ETL procedures and steps, then moving to the Azure ETL tool, that is Azure Data Factory. So what is ETL? It is a very common term of data warehousing. The purpose of ETL is to move data from different data sources to the destination after going through the number of processing steps, or we can say the transformations. It has three basic steps: extraction, transformation, and then loading. To extract the data from different data sources, first of all, we need to understand what can be the sources. Sources can be of any form. It can be a flat file or it can be a database source like MySQL, Oracle, Teradata or any other. It can also be in XML or any other outsourced integrations. The number of sources depends upon the tool you are using for ETL. Each tool provides different sets of sources, but the most common, which I mentioned above, are provided by all tools because these are the basic ones. And then we will have a transformation phase for apply some calculations. I will elaborate some examples of what kind of transformations be in the upcoming slides. And then finally the data will be loaded into the data warehousing. Upon arrival, the data should be cleaned and processed, so it will be useful for our further proceedings, which can be generating reports using any visualization tools related to business intelligence, or creating dashboards for customers, or applying some machine learning or statistical models to get some insights and much more. This all steps needs monitoring also for any successes and failures, so we need a kind of monitor. Again, it depends upon any tool you are using for the ETL purpose, that how monitoring takes place in that tool, or how you can configure the recovery mechanisms in case of failures. So for extraction purpose, data is coming from a number of sources. If we take an example of a bank, what can be the data sources? Customer open an account and the relevant data including his demographic details will be taken up by the branch official, and eventually it will come up into the banking system. Let's say for a day there are around 300 to 500 number of customers who visited different branches to open an account. To keep it simple, we are not going deep into the technicalities. Our purpose is to just focus on a high level details of the ETL process. Once all the data for a particular day is present into the banking system, then at a given time process for extraction will run and it will fetch all the data it generates for accounts and customers in the form of flat files. These flat files will be placed, let's say, on an FTP server where it can be consumed by daily ETL process. Once the data is present at FTP server, then we need to get data loaded into the database area. We can say it as a staging area, meaning it will be in an organized form rather than in flat files. It is a raw data and we cannot skip data before getting it into the staging area because it may contain important information. Once all the raw data of those flat files is available in the staging area, now we can clean it up, a few of them which seems a spam or totally irrelevant data. After extraction, we will have our transformation stage. As the data is in the raw format, and processing steps are required to make it usable. If we do not clean this data, then we will be unable to generate useful insights from the data. Let's take an example of what kind of transformations be needed. For example, if the user wants sum of sales revenue which is not in the database or not in the staging area, then we can apply function to get the sum of sales. Similarly, if the first name and the last name in the table are in different columns, it is possible to concatenate them before loading. Another example of conversion of units of measurements like daytime conversion, currency conversions, numerical conversion, etc. We can also check if there are nulls in the required fields, or replacing nulls with zeros, or male to M and female to F. It depends upon the number of requirements or what kind of requirements are. These are all examples of transformations. It can be done in a tool you are using or by writing custom steps. Finally, data is ready to load into the data warehouse. Loading should be optimized, means your whole ETL process should be efficient enough to not unexpectedly taking much time in loading. In the previous slides, we were talking about ETL tools. So if you are wondering about the most popular tools which are available in the market to achieve the purpose of ETL, then these three tools fulfill the purpose effectively. I have personally used Informatica Power Center many times to create ETL processes which are basically workflows in Informatica. It has a number of transformation components available and it has a separate monitor window for monitoring workflows. This is a separate topic to explain completely about Informatica, and we will deviate from our original agenda. So let's keep it stuck to this, and if any one of you have any question related to Informatica, you can ask me in the comment section. I will try my best to answer them all. Along with Informatica, there are others as well, like Microsoft's SSIS and Oracle ODI. By the way, it is not necessary that one should have an ETL tool for ETL purpose. One can also write a custom ETL procedures in SQL language to fulfill the purpose. So these were the basic concepts of traditional ETL, and now we are moving to the ETL in cloud, that is Azure Data Factory. Here the cloud provider is Microsoft Azure. Same three steps for ETL are included in ADF also. As in traditional ETLs, there were tools. Similarly, Azure also provides a way to achieve the ETL purpose via ADF Designer or by writing custom JSON code. In ADF, the cycle for ETL is called pipeline, same as workflows in Informatica. There are numerous number of sources for Azure with around 90 connectors. For transformation, data flows can be used. This is the kind of functionality used in ADF Designer to create graphs for different transformations. And finally, loading destination into the data warehouse. Here the data warehouse can be Azure Synapse Analytics or any other. So why do we need ADF in cloud? If there is no ADF, then custom services needs to be written to integrate with different sources, and there are many sources. It will definitely be a hard task. It can also be expensive and difficult to monitor. That is why Azure provides the platform where one can write ETL process through ADF Designer or can create pipelines. Let's move to the main steps in ADF. For extraction, there are around 90 connectors to connect with different sources. It includes almost all kinds of sources from flat files to DBs, Twitter, Facebook, AWS, and much more. As we move data into the staging area in traditional ETL, here we can move data into the centralized location which serves as a staging area for cloud. Moving of data can be done by using copy activity in Azure Designer. This is the snapshot of sources, which we call 90 connectors. You can see it includes structured sources, unstructured sources, cloud ones, and all coming at different intervals with different speeds. So we need to handle them in the ADF Designer or by writing custom codes. After data is arrived at a centralized location, which is called staging place, it can be further analyzed or transformed by using compute services or ADF mapping data flows. It can be done in two ways. Either use data flows from ADF Designer. Data flows enable data engineers to build and maintain transformation graphs without needing coding information. Or it can also be used by doing coding manually to execute transformations on compute services such as HD Insight, Hadoop, Spark, Data Lake Analytics, and machine learning. For example, you can collect data in Azure Data Lake storage in a centralized location and then transform the data later by using Azure Data Lake Analytic Compute Service. Or you can also collect data in Azure Blob storage for unstructured data and then transform it later by using an Azure SD Insight Hadoop cluster. After data is refined by applying required transformations, it can be loaded into Azure Data Warehouse, Azure SQL Database, Azure Cosmos DB, or whichever analytics engine your business users can point to from their business intelligence tools. After successful deployment of data integration pipelines, monitor the workflows or pipelines for successes and failures. Azure Data Factory has built-in support for pipeline monitoring via Azure Monitor, API, PowerShell, Azure Monitor Logs, and health panels on the Azure portal. This is the overall flow for the ADF. Here you can see this is the step-by-step diagram which we discussed in the previous slides. Data is coming from the unstructured and structured sources, and then it is ingested and then stored into the staging area. After that, preparation and transformation is take place and finally loaded into the data warehouse where business users can take benefit from it. This is it from my today's lecture, and please do suggest me for any topic video lectures related to data warehousing, cloud, or ETL concepts. And please do not forget to provide your valuable feedback. Thank you so much.